Hey guys.
Hello.
So we're building a kit today, and let's see, what do we got, Addie?
Looks like it's a Midi in-me kit, and we've got, of course, the board. We have a 1x3 male header. You can choose to use a female header if you'd like. For connections, we've got a 5-pin DIN connector.
Midi
jack thing.
Yeah, 5-pin DIN.
Yep.
Old school.
Yep. And then we've got two 70 ohm resistors and a 1K resistor, a 1N914 diode.
They're stuck together, Addie.
I know, they're buddies. We've got an 8 DIP little socket, and then we have what looks like what is it? Oh,
it's an opto isolator.
Yeah, what is it?
For protecting.
6. I'll have to figure out the numbers.
Yeah, the one that I'm using here is a 6N138.
Ah, yes, okay.
But I'm not sure if that's the one that'll be going out to them, so we'll see.
We'll
We've got
see.
some other ones on the way that we're going to test.
Yep.
Okay, and then of course there's 4.
4 1x2 pin standoff things so that you can stick it in your breadboard.
Yeah.
So.
Alright, the basic idea behind this board is that it allows you to get a MIDI signal from a computer, a sequencer, a MIDI keyboard, a MIDI drum kit, you know, whatever, and be able to get that information into a microcontroller like a propeller or whatever in a very built-in easy way. So
Okay.
this thing is, yeah, it has all the electrical protections that you need to talk MIDI, because it's like a old school voltage swinging up and down kind of, yeah, crazy talk.
Okay.
Not like I2C or something, which is very small voltages.
Right. How common is it for 5-pin DINs to be used?
It used to be the most common thing, really. Like keyboards and mice and power plugs and all sorts of video cables. They all use DIN plugs like that. Alright, so where am I going to start? I guess we could start with that IC socket there. That would be easy.
Okay.
So on the IC socket, basically what I'm going to do is put it in its spot, minding that the notch here on the socket lines up with the notch on that silk screen. So that's easy.
Yep.
And then I need to be able to hold it in place a little bit. And there's a lot of ways you can do this. But the way that I like to do it is just to bend slightly over a couple of the pins. Not so much that you can't clip them off when you're done. You don't want to fold them all the way over. But if you just bend the corner pins in opposite corners over a little bit, then that socket's not going anywhere. It'll just stay put. And that makes it a lot easier to solder it. So when you flip the board over, it doesn't fall out. Yeah, that's really easy. So we're using soldering iron at 350 degrees Celsius, 650 degrees Fahrenheit. We're using fine electronic solder of a 60-40 mix. We don't use none of that silly ROHS stuff around here. It's got lead in it.
Tasty.
Yummy. Lead is bad for you. Don't eat lead. Alright, so soldering these is really simple. We just need to make sure that our iron is clean, shiny. This gets used a lot, so it's already tinned and everything. And then when you touch your iron to this, you need to touch the pin, and you need to touch the what do they call that stuff?
The pad.
The pad. And then once you're touching both of them, you can touch your solder to the iron close to where that connection is, and the solder, being rosin core, will flow right down into that hole and make a nice perfect electrical connection and you really don't need very much of the stuff for IC socket pins. It's really less is more kind of thing. You can tell when they're happy too, because they get a nice shiny look to them, and it's not bubbled up above the top at all. It's all sitting right down there in the hole.
Kind of soaks in like a sponge.
Yeah, totally. Wicks right in there. It's nice. And I don't know if we've mentioned this before, but when soldering, there's a lot of smoke that'll come up off of rosin core solder. You don't want to breathe that stuff. So make sure you do your soldering in a well ventilated place, and don't do it with your face right over that, right over the fumes. If you're in a small area, make sure you use a fume extractor. That'll help a lot. It's a little fan that you can set right over your work, and it just blows the stuff away from you. Okay, so let's take a look with our inspection tool here. Yeah, looks really good. Alright, so what I'm going to do is clip these off and take a couple of detailed photos for you guys. Alright, Addie, so which resistor do I put where?
So R1 is going to be the 1K.
Okay,
which is the blue
so
one.
That's easy.
Yep. And I misspoke earlier. I said there are two 270s. It's actually one 1K ohm resistor, one 220 ohm resistor, and one 270 ohm resistor that folks will be getting in the kit. So R1 is the 1K.
Alright, so I'll install that.
Yep. R2 is the 220.
And when I put the resistors in the board, I fold the leads over so that it stays put when I go to solder it. Alright, so that was R1.
Yep. R2 is the 220.
R2. This is fun. I like building electronics. Let's see, R2 you said?
Yep.
Okay, I'll get those in there. Make sure you do it right. Don't put any of the wrong stuff in the wrong spots.
Yep. And then R3 is 270 ohm resistor.
Okie dokie. Might be this one. They don't have any polarity, but I like to put them in the same direction as the other ones just so it looks pretty.
Mm-hmm. You could probably put the diode in too at this point.
Okay. So we're just going to solder up all 4 of the things that are in a row here. The diode, the resistors.
So with the diode, there's going to be a black band signifying the cathode. You want to make sure to line that up with the silk screen.
So on this particular diode that I'm using here, it looks like the band is light colored. Can you see that?
Here, let me see.
I have the magnifying glass too if you need it.
It's orange.
So this one has an orange band. So I'm going to make sure that the band goes towards the stripe. And you get variation in diodes. Some of them will have a black stripe on them, and some of them will have other stuff. So.
Some will be silver if the package is black.
But this definitely has polarity, and you definitely have to do it the right way. If you don't do it the right way, the circuit is not going to work.
Let me just make sure. Yep, okay. That looks good.
So I'm going to switch it when she's not looking.
Mm-hmm.
Alright. Okay, get that kind of centered so it looks good. Okay. I'll fold that one up over. Yeah. Okay, so now that we've got all of those installed and in their various slots there, we can actually solder up the back. So I'm going to flip on the iron. We're going to use the same temperature for these as we were using before. And that'll work just fine. It's really not that bad for soldering. Through-hole stuff is pretty easy. Even if you're new to it, it's pretty easy to figure out what you're doing and get it working. Now when you solder the through-hole components like this, you gotta make sure that your iron is touching the leg of the component and the little pad that it's going through with the hole, so that both things are hot and the solder can attach them together. It's really important to make sure that both are in contact with the heat. That'll make it a lot easier for you guys. Alright, that's those all soldered, and now I'm going to clip them off, and we'll take a little up-close photo so you guys can see what's going on there. So now that we've got those soldered up, what I'm going to do here is install this opto isolator in the socket, and you have to make sure your pins are bent over enough to go straight into this thing. A lot of them will come with the legs splayed out a little bit, and you have to put them against a flat surface and then angle them in until they match, 90 degrees to the body of the IC. So that looks pretty good there, and the next thing we're going to do is add in the jack here, and it should fit in very smoothly, very easily. And we're going to clamp this up in our helping hands, and if Eddie, my lovely assistant here, could grab me the other set of helping hands, that'd be useful. You don't have to have two to do this job, you could just use one, but I think I'm going to try to do it with two this time. We'll call it the advanced class for you guys out there who have some extra toys. Okay, now that we've got that all set up on the board, the jack is very squarely placed down against the PCB and held in place. We're going to solder a couple of these in here. And just like before, it's always important to get your heat on both the pin and the hole that the pin is in. Doing that will make this job a lot easier. These are structural connections as well as electrical, so you need to make sure that you put enough solder in these to securely hold it as the plugs are plugged into and out of this jack. Okay, we've got all those pins soldered up nice and pretty. Now I think it's time for us to start doing a little bit of talking about how to mount this guy. So there's a couple of options here, as with most of our boards. The one I'm going to set up today is breadboarding this, but there's also mounting holes. You could screw this to the inside of your project. And we still got some pins left over from the Turn Me video. Take those out of here. Okay, so it comes with these four things here. And basically, to solder these in, you want to take the longer sides of them and stick them in the breadboard. If you have some access to something like hemostats, then they might come in handy for helping you, get those in securely. I know I use them all the time for this sort of thing. And line up the next set with the distance between the holes and make sure they're on the same rank there. You can double check it, triple check it, whatever. And then that'll give you the offset for the back ones. There. And then the last one is simple, because it's just connecting the dots here between the corners. So we get those all set up, and then our board should sit firmly down on it, and it's all square and in place and ready to go. And then we can solder them up using that as a jig. And again, it's very important to make sure you're touching the pin and touching the pad that the pin is in. And on these, you don't want to overdo it with the heat, because if you do, you'll melt the plastic on those little headers, which can leave for some sloppy results.
But keep in mind that these aren't electrically connected to the circuit, so, you know, if it's a sloppier job, it won't really make any changes to the circuit itself.
We're not worried about electrical connection here. You're worried about making sure that structurally it's 90 degrees to the board, so that it always plugs into breadboards nice and square. Okay, there's that. And now that we have those soldered up, we can talk about the last thing here, which is the connector to the microcontroller. Now what's going to come with the kit is a 3-pin male header, and you'd just be putting that in here and soldering it up as you'd expect. Sticking to my finger. It looks something like that, but we're going to be a little bit different and hook up a female header that we cut down from an 8-pin to a 3-pin. And you could do this too. We just didn't want to include them because they're cut down, they have a rough edge, but this one's for me, so I don't mind if it has a rough edge. So I cut down a female header, and I'm going to solder that in here real quick. Alright, last step here for assembly. Soldering up this female header here, and I'm going to make sure that it's nice and square there before I put any solder on any of the pins. So once you get it started with solder, it really is a difficult process to remove it again. So you want to make sure you got that thing held securely ahead of time. So once you solder that second pin, it's not going anywhere. Okay. One more.
No escape for the headers.
Alright, so that's how you put together the ToyMod Midi in Me. And we're going to do a little bit of demonstration here on what you can do with this guy. We have the Midi in demo running on the propeller back here on the propeller professional development board with the Midi in put on the breadboard with just power, ground, and then one line going to, I think that's pin 12 on the prop. And the Midi port is connected to this Midi controller, which is pretty standard stuff. And the serial line is connected via the USB to the development board to the laptop here, and we've got Parallax serial terminal running on here. And basically what's going to happen is when I press keys or change settings, it's going to tell us which channel the Midi device is talking on, which key was pressed or unpressed, and that's note on and note off in Midi speak, and which setting was changed and what it was changed to. So I've got the octave all the way down here, so this should be note 0. Channel 3, note 0 on. Channel 3, note 0 off. I can also play chords. I'll play a C major. Those go on, and when I let go. So polyphony is possible here. Now let's change one of these. Like these switches here, they go from 0 directly to 127. So channel 3, controller 2, value 127 because I turned it on. And if I turn it off, it goes to 0. Same thing with switch 2. is controller number 3 instead of controller number 2. And I can also do these like knob adjustments, right? I can turn this all the way up to 127 as well. So I've got that, and I've got this slider, and that's the same story, right? And then this mod wheel also shows up as controller number 1. So, you know, whatever your device has, it has, but, you know, it's just an example of one that we have here. And you could be using a musical input device, or you could be using anything else, like a Midi drum kit, for example. You could be beating on it with sticks, and that could control your RGB light display, or have servos, or a giant robot that you drive around with with a MIDI flute, you know, a MIDI wind device. You know, you could drive your robot with it. Yeah, it's all completely possible here because it's all just a bunch of numbers at the end of the day.
Right.
So anyway, that's the demo code. I hope you guys enjoyed it.
Yep.